You should learn assembly language, and I'm going to tell you why. Hey, what's going on guys? This is Brace, and in this video I'm going to tell you why you should learn assembly language. Not to be a great assembly programmer, but at least to understand how it functions. I think learning how to code in assembly is to appreciate all what C language offers you. And if you want to learn C, in order to appreciate all the great things that Python gives you, that's also a great move. So assembly, C, and Python are three main languages you need to know if you want to understand how code is working and how things look like underneath the hood. I even would say assembly and C, then you're free to choose whatever language you want for your backend programming. But the reason why I mentioned Python is that Python is written in C, and C itself is written in C, but you can think that the first C was coded in assembly. So to summarize, Python is written in C, C is written in assembly, and assembly is the human readable form for machine language, which is a bunch of zeros and ones to put it simply. Alright, so enough talking, and let me show you how we can write our first hello world program in assembly. So we will need to run on an IBM compatible PC with an x86 64 processor, which is a 64-bit of virtual memory address. And also we'll need to have a copy of Linux kernel. And in order to check out the type of your processor, just simply type arch to check out the architecture. Or you can type uname-m. It will give you the same thing, x86 with 64-bit of virtual memory. We will need also to install the NASM assembler program, which is the Netwide Assembler for the Intel X86 architecture. An assembler works as a compiler, but for assembly language. So go ahead and install that, sudo apt-get install NASM. Alright, and as I said, I'm working on Ubuntu distro, but this will work on any Debian based distro like Mint, Kali, any Debian based distro will do the same thing. And there are many assemblers, not only NASM or the Netwide Assembler, but there is also Microsoft Assembler, which is MASM. There is also GAS, which is GNU Assembler, but in this tutorial we will work only with NASM. Alright, so let's write our program and I will try to explain everything while typing. And I'm going to work with nano. And let's create a file hello.asm. I would like also to mention that any assembly program can be divided into three sections: the text section, the data section, and the BSS section. The text section is used for keeping the actual code. This section must begin with the declaration global start, which tells the kernel where the program execution begins. And global keyword followed by _start is essential for the linker, which is very important later on when we will run our program. So this is the text section. And by the way, in order to add a comment in assembly, you just add semicolon. Okay, so this is a comment. Also, a multi-line comment can be added by typing / ****. Okay. This is a multi-line comment. The second section in any assembly program is the data section. And the data section is used for declaring data or constants. So this data doesn't change at runtime, and you can declare various constant values, file names, buffer sizes, anything you want in this section. And you can think of this as the keyword const in JavaScript for constants declaration. And the last section is the BSS section, which is used for declaring variables. You can also think of this as the keyword let in JavaScript for variables declaration. Alright, so let's go ahead and write our program, and I will try to explain everything while typing. We will write the text section first to inform the kernel where the execution of the program starts. So we'll say section.text. Then we want our keyword global _start. So as we said, this is to inform the kernel where the execution of your program starts, and also it's very important to be declared this way for the linker. And we will use the ld command in order to link this file, but before we will use the asm file. As you can see here, this is hello.asm. We will need to compile this file to an object file. Then from the object file, we will use the linker in order to convert it to an executable file. Okay, so I'm going to show you all of that later. Then we'll type _start. And this tells the linker where is the main entry point. So what we're going to type next might look overwhelming, but believe me, it's very easy. So we're going to move edx, which is a register. And the concept of registers is very important if you want to understand assembly language and the relation between memory and registers. So we're going to talk about that maybe in later videos, but I'm going to mention this very briefly. Here simply we are storing in that edx register the length of the message that we're going to type. We also want to move or store in ESX register the message. Okay, so this is the message that we want to write later in the data section. Next, I want a file descriptor, so we will move to EBX register number 1, and also I want to move to EAX register number 4. And this is just a system call number, and we're going to talk about system calls later. Finally, we want to have an integer, and this integer is 0x80. And this is simply to call the kernel. So you can add a comment here if you want by typing semicolon on the same line, doesn't matter. This is to call kernel. So here above in move EAX number 4, this is for system call to system write. Let me just add a comment here. This is for system call sys_write. Okay, and notice this is EAX, and also I will move to EAX number 1. And this is also a system call number, but instead of writing in the system, I want to exit the system. So let me add another comment here, system call for sys_exit. And again, I want to call the kernel. So we're going to type int 0x080. All right, this is the text section. The next section is the data section. Until now, we didn't write hello world. So all of that is just the entry point, so the kernel can understand where exactly the program must start and the instructions that the kernel must follow. So section.data, like we did with section.text, and here we will type message. You can type anything. You can type text, you can type message, you can type message, any name that has a meaning, okay? Think of this as a variable. This is more like a tag to be assigned to the memory address where data exists. So whenever we use this message name later in the code, the assembler will locate this data in memory and will replace the message with the memory address. Next, we'll type db, which stands for define bytes. So we want to define several bytes. And these bytes simply is whatever inside the string. So here, hello world. So each character of those is a byte. And as you know, each byte is composed of 8 bits. And I want another argument here, so should be a new line. And a new line in assembly code must be written in this way, 0xa, or you can simply type 10. We'll do the same thing. And let me show you. If you will go to Python, and if you will type 0xa, it will give you number 10, okay? So if you want to check out what is the 0xa actually, this is exactly like you would type in Python \n, just to move to a new line. So whatever 10 or 0xa, it will do the same thing. And the last line in our hello world program, I know this is quite a lot just to print hello world, but this is what I was saying at the beginning of the video. You need to learn assembly in order to appreciate Python. In Python, you would type print hello world, that's it, just one line. In assembly, you will need to type all of that with these teeny tiny little precisions that are essential in order to run your program. So the last line is len, we want the length, and the length should be equal to, followed by a $sign, and you can just count the number of characters. So we have 1 byte, so 1, 2, 3, 4, 5, 6, 7 with the empty space, 8, and so on. But just to save yourself the headache, you will type hyphen and that variable or that tag message. And that's all. This is all what we need to do in assembly in order to run a hello world program. Okay, so let me just save the file, hello.asm, okay, Control X to exit. Now we will need to assemble our code. So we'll use NASM, you just increase this for you guys. So you will type NASM followed by -f, format flag, ELF64, and this is an object format. This is the 64-bit version of the executable and linkable object format. So this is very essential before we're going to convert the object to an executable file. Okay. So again, the ELF64 is the 64-bit version of the object format and the executable format as well. Then we want to create an output, and we want to name that file hello.o, which is an object file, and the input file is hello.asm. Okay, and this will produce a file called hello.o. Let's take a look. There you go. We have here hello.o and our main hello.asm. But still we cannot run it. We need the linker to link it to make it an executable file. So there is a linker built in Linux called LD, and we'll make use of that to link the hello.o file, this object file. So if you want to take a look to the manual of LD, you can do that by typing man LD, and it should give you a manual on everything for the LD, the GNU linker. Just you can browse the file and read everything if you are interested to enrich your knowledge. Okay, so let's quit that. Now let's link our hello.o file, and I want my output to be just hello, and this is going to be an executable file. Okay, let's take a look. Now hello is in green highlight with no extension. We have produced an executable file, and to run it you need to type ./hello, hit enter, and there you go, hello world. Alright, so you saw how hard it was to type and run a very simple program just to print a string on the screen. We needed to type a lot in order just to run hello world program. And I think that every programmer should at least know the basics of assembly. Again, not to be a great assembly language programmer, but this will definitely help you if you're going to learn something like C or Python or C++. Alright, so thank you very much guys. If you liked this video and want to see more, please let me know in the comment section below. I'm ready to do more of assembly even if there's only one person requesting this. Don't forget to subscribe and hit that notification bell, like and share the video. That would be all for today. Until next time, peace out.